Welcome to part 5 of the series where we're reproducing this shoot 'em up designed by KidsCanCode in Monogame, Love2D and Pygame. I'm doing it slightly differently this time in that we're going to be looking today at the Love2D Lua version, and there's a good reason for doing it slightly the wrong way round. If I just bring this into play so that we can see what this one is doing, we're actually combining episodes 5 and 6. So we're doing improved collisions using a circle collider and also rotating the images. So if I just play this for you to get the see what we're up to. Now this is in debug mode running in Love2D. So as you can see, we've got this time falling mobs, meteorites of different sizes, and as they're falling they are rotating, and round the outside of each of these mobs we've got a rectangle. So if you look at each of them, we've got, let's take this one here, which is a big one. We've got a red circle which kind of occupies a fair bit of it. Then we've got a blue rectangle which is in its proper horizontal and vertical alignment. And then we've got a rotating green rectangle which is kind of following the rotation of the meteorite. Bullets are at the moment, I've disabled the image so that it just fires up with, as you can see there, a yellow rectangle, and you might just be able to make out a red circle at the top of it, and the player has a red rectangle with a blue circle. I've just realized that's not quite on center, but anyway, that's not too bothered about that. So what we'll be investigating today is, first of all, using circle colliders, and secondly, and more importantly, is how to draw a rotated rectangle, which you would have thought would have been as simple as anything, and in fact in Love2D it is. So that's why I'm doing Love2D first, because drawing a rotating green rectangle is dead easy, whereas in Monogame and Pygame it's actually quite a performance. So let's shut that off so we can get back to the code. Now the first thing is, in the main, if I can just increase the font there, we're going to import some more images this time. Again, I'll put links to where to get these images from. I may well have already done it, but I'll just make sure. So we're going to, we don't need all that you see in this list here. This is a kind of a comprehensive list for the entire finished game, but we do need this meteor brown lists here. Those are the ones that we need. I think we did use before meteor brown underscore med1 was the one that just had the single meteor. So we're going to be loading in a number of those. So in love.load, this bit is the same up to here. Now load images, we did start that last time where we had the sprites.background and we loaded in the image sprites.player sprites.bullet. Now this time I've changed it from sprite.meteor singular and then loading in a single image to sprites.meteors with an S as an empty table. And then we've made a local list here. Now remember, in Lua, tables can act as dictionaries or lists, so this is using it in its kind of list format. So we've just listed the names of the meteors that you saw in the image folder here, just creating a list of, I think there's 8, 1, 2, 3, 4, 5, 6, or 7 actually, no, yeah, 7. So then we're inserting those meteor images into our sprites.meteors table by just using this sort of image stroke and then using the 2 dots which concatenates the string of img / with whatever the name of the meteorite is, and then it then loads it in and puts it into this table, so that we have a whole table containing all these meteor images. So that's how that's done. After that, the mobs are done slightly differently in that we're now running a loop as we did before for 8 events to put 8 mobs in. But this time we're passing in obviously the list of mobs that we want to add to, but we're passing in sprites.meteors, and then we're choosing a random, using math.random, between one of the 7 meteor images that we have put in. So this line here chooses one of these 7 at random and makes a mob out of it. So the mob class is where some other changes have occurred. So I just wanted to show this first, and then the rest of it is pretty much the same as it was before. Now if we go to the mob class, again, let's increase the font here. So we've got some new stuff in here because we want to rotate the rectangle. Let's go through this in time. So as before, we've got the local class. We're making a mob out of it, and we're loading in the rectangle class which we used before. Now we've now created a new class called circle, so that we can use a circle collider as well as a rectangle collider. So I'll just show you the circle class. That's inside our lib folder here. So we've already got the general base class. We've also got the rectangle. Now we've got the circle. Just show you how the circle works. So to make our circle class, I don't know why I've duplicated that. That shouldn't be. There we go. So we've got we're incorporating the general class, and then we're making this new class called class derive circle. There's a little bit of a description of how it works there, so have a look at this for yourself. And then this is the constructor here, so we're taking an X and a Y coordinate and the radius of our circle. So it's relatively simple. So this sets up the circle, and then we've built in here an intersects routine, much like we did in the rectangle. If I just show you rectangle just to remind you, we had a rectangle intersects inside the rectangle class using this simple maths here. So if we go to the circle one, we're again just using some Pythagorean theorem to work out. Now again, I didn't write this myself, I just found some maths online and kind of adapted it to fit in with Lua. So again, relatively simple. All we're doing is checking to see whether the circle of this object is intersecting with the circle from another object, so that it's quite a generic one. So we can test this against mobs and players, mobs and bullets, whatever. So we're just doing a generic circle intersection here in the circle class. Again, we've got to set properties. We can get the circle again, we can get the center, we can set its X value, update its position, the same as we did with the rectangle. So you can have a look at that for yourself and see how that works, but it's very similar to the rectangle class. I'll just save that. So let's come back to our mob. So we're getting now incorporating the circle class as well, and then with our mob new, again we're passing in the sprites. Now the sprite has been randomly chosen from one of 7, and then otherwise it's acting much as it did before. We make a rectangle from that sprite using its dimensions and so on, and then we're also having we're making a circle. So self.circle, and then we're calling the circle constructor here. So we're giving it initially a X and Y position of 0, and then passing in the radius, which we have calculated from using the smallest value of the width of the sprite and the height of the sprite. So we're just making it half of whichever of those two is the smallest by using math.min. So that gives us a reasonable radius. You could, if you wished, if it was too big, you could always multiply that by some kind of divisor to scale it down a bit, but that seems to work quite well. So we're setting up our mob as before, but we're now adding our self.circle. Now in the set properties, one thing we wanted to do with this mob is to rotate it. So we've added a new property here called rotation, which we're setting at 0. And then we're setting a rotation speed, again using math.random. Now in Love2D, the rotations are measured in radians, not degrees. I believe the Pygame one works in degrees, but so we're having to take care of that by using our rotation speed as somewhere between minus pi and pi itself times a half, so that we can get a maximum of 1 rotation per second. So that 1 rotation per second would be math pi over 0.5. So it's somewhere between obviously a smaller value than that and greater, and the rotation direction is controlled whether it's negative or positive. Now these two are some new variables that we've put in, which is the offset in the x direction and the offset in the y direction, which are used in the love.draw. So we're just calculating that from the rectangle's width and height. As before, we're choosing some random values for the speed and position of the starting mob, which is being reduced if it's in debug mode, so it's slowing it down. Then down here, we're setting the position of each of the rectangle by using set x and set y based on these values that we generated up here. And then finally doing the same with our new circle. So we're setting the circle by updating its x and y position, which was 0. So this sets everything up in order to allow us to rotate our rectangle and of course the graphic that's contained by the rectangle. Now in the update function, the first thing we do is we want to rotate our graphic and our rectangle that it contains. So we have written this new routine called mob.rotate, which is here. So let's go through this one. So we pass in delta time, and then the rotation, which started off at 0, is then increased by the rotation speed multiplied by delta time. So this will give it a small rotation depending on the speed that we set initially and delta time. We're then checking if the rotation is greater than math.pi times 2, in other words, has it done a full circle, then we're going to set it back to a rotation of 0. So that's actually relatively simple. It just gives us a number, which is the rotation amount. Then after we've updated it, we're doing the updating the position of the rectangle, and then we're updating the position of the circle based on the position of the rectangle. So this update position is only changing the x and y coordinates of the rectangle and the circle. It's not taking into account the rotation, just the position. Again, we're checking if it's gone off the bottom or the sides of the screen by resetting the properties if that's the case. Now the next bit is where we're actually drawing the graphics here. So initially we set the graphics to white so that we can actually draw the sprite here. Now this time you'll notice that we've got some extra values in here. If I hold that over draw. There we go. So love.graphics.draw. We're drawing a drawable, which is the sprite, at position X, which is self-rect X, number Y, which is the offset. As you can see we're drawing our drawable at position X, drawable comma X, and we're setting X by taking the rectangle's X position and adding the offset of X. And we're doing the same then with the Y position. We're doing self.rex.y plus the Y offset. So that is setting up the position with our now rotated rectangle. Then it says number R, which, oops, I've lost the thing again. So we can get it back. Okay, number R is the rotation, so we're passing in self.rotation. Then we've got the scale in the X factor, which is SX, which we are not scaling, so that's nil. Scale in the Y direction, which again I've put as nil because we're not scaling it. Then we've got the offset in the X direction, followed by the offset in the Y direction, which are of course these two here, self OX, just slide this along, and self OY. So this is slightly more complex than it was before, but we're still basically drawing the sprite in a rotated fashion. So that's quite neat there, and that draws the sprite with its rotation. Now the next thing we're doing is to change the background color to red, sorry, not the background, the drawing color to red, and drawing a red circle by using love.graphics.circle, using a line because we don't want it solid, and then it's simple, just giving it circle X, Y, and radius, and that just draws our circle. That's easy. Then we're changing the color to green, and then we're doing this new function called rotating rectangle in line format, using the center of our rectangle X, sorry, the center of our rectangle X, the center of our rectangle Y, width, height, the rotation, and the offset. So again, we're passing in quite a lot of information into this brand new function called rotating rectangle. Now this is the way rotating rectangle works. If I just untick that. So this is a Lua thing. So there doesn't appear to be anything similar in Monogame or Pygame. So what we're doing is we're taking the current state of the graphics and putting it onto some kind of stack. We're then translating the graphics using the X, Y coordinates, rotating it by A. We're then creating a rectangle using the supplied parameters here. And then once we've drawn it, we're popping it off of the stack. So that way we're kind of doing a drawing, and I'm guessing perhaps under the covers the Monogame and Pygame works in a similar way, but this was fairly easy to comprehend once you've looked at a tutorial how to do it. So you're basically just sort of doing a temporary drawing and putting it into the buffer ready to draw the picture, and then returning everything back to what it was like. So fairly easy. And then once you've done that of course just draws your rectangle. So rotating rectangle, and you give it these things here, actually draws it on the screen. Then finally we're changing the drawing color to blue and just drawing the basic rectangle as normal. So it's love.graphics rectangle, and then we're drawing a line with its X and Y position, width and height in the normal way. So that's the way that Love2D handles drawing a rotated rectangle. It's slightly complicated in that we have to pass it all these different things, height, width, XY position, translation and offsets, but it does do the job quite efficiently, so that works. So let's go back to our main. So that will now update and draw our graphics as before. So we've now got the difference with this one and the previous episode is that we've now got circle being drawn as well as rectangles. The circles are themselves colliders, and we're rotating the images. So I'll just run that again for you just so you can see. Just drag that over. So if I fire the bullets, we've got a combination of a yellow rectangle with a red circle at its tip. Each of the mobs has a red circle and a combination of a green rotating rectangle and a blue static rectangle, which follow the mob itself. So that's how we are now using both circle collisions and rectangle collisions. Just to show you how we're making use of those circle colliders, if we go back to the check mob bullet collisions which we had before and the check mob player collisions as we did before, all I've done here is to comment out the if player.rect intersects and changed it to if player.circle intersects with the mob get circle. So very, very similar, except we're now using the circle colliders instead of the rectangle. And the same with the check mob bullet collisions. We were initially doing a choice whether the bullet rectangle is intersecting with the mob's rectangle. We're now just using the bullet circle. Is it intersecting with the mob circle? Reason for doing it is explained nicely in the original video, which I would encourage you to look at. So episode part 5 and part 6, if you can look at those two before coming back to here. But that should explain roughly what we're doing. And the reason for doing it first in Love2D is it is actually very, very simple to get the rectangles, a rotating rectangle, drawn by using this Love2D kind of a way of doing things which appears to be unique. Okay,